Right now, moving through the outer dark at 58 kilometers every single second, an object older than our entire solar system is leaving it behind for good. No comet ever tracked by human telescopes has carried a chemical signature like this one. No object confirmed to come from outside our solar system has ever been examined by two of the most powerful observatories on Earth and in orbit, independently in the same year. This is not a passing rock. It is a fossil from another star system, and it just got a second confirmation nobody was fully expecting. Stay with me, because the last part of this story is still an open scientific question. If you're new here, this channel breaks down real space missions and real discoveries. No filler, no fiction. Subscribe if that's your thing. It costs nothing. Let us go back to the beginning. To understand why this object matters, you first need to understand what almost never happens in astronomy: catching something from outside our solar system while it's still passing through. For the entire history of telescopic observation, every comet and asteroid ever tracked has belonged to us, in the sense that it was born here, orbiting the sun on some long looping path that always brings it back. That assumption was reasonable. It held for centuries because nothing ever contradicted it. Interstellar space is so vast, and stars are separated by such enormous distances, that the odds of a piece of another solar system drifting close enough to Earth for us to actually see it seemed vanishingly small. Then, in 2017, that assumption broke for the first time. An elongated tumbling object called Oumuamua sped through the inner solar system on a trajectory that made no sense for anything native to our sun's gravity. It wasn't looping. It was passing through once, never to return. 2 years later, in 2019, a second interstellar visitor arrived, Comet 2I Borisov, confirming that Oumuamua hadn't been some impossible fluke. 2 objects in 2 years, after 0 in all of recorded history. Finding either of those first 2 objects required a specific kind of luck. An interstellar object doesn't announce itself. It looks, at first glance, like any other faint smudge of light crossing a telescope's field of view. Thousands of asteroids and comets get flagged every single night by automated sky surveys, and almost all of them turn out to be ordinary residents of our own solar system. What separates an interstellar visitor from all that background noise is its orbit, and an orbit only reveals itself after you've tracked an object's position carefully over days and run the numbers. Oumuamua was only recognized as interstellar after astronomers had already been watching it for days, once the shape of its path made a closed solar orbit mathematically impossible. That's the needle these survey telescopes are built to find in a haystack of ordinary rocks, something moving too fast, on too straight a line to ever have belonged here. On July 1st, 2025, the Atlas Survey Telescope, a NASA-funded planetary defense system based in Rio Hurtado, Chile, built specifically to watch the sky for anything dangerous, caught a third one. Astronomers quickly calculated its path and found something unambiguous in the mathematics. An eccentricity of roughly 6.1, a number so extreme that no object bound to our sun's gravity could ever produce it. Anything gravitationally tied to our solar system moves in a closed loop. This object was moving in a straight, one-way line through it. It had a name within days: 3I Atlas, the third confirmed interstellar object in human history, discovered while it was still inside the orbit of Jupiter, traveling at roughly 137,000 miles per hour. Read that again? The number to remember for everything that follows is 137,000 miles per hour, and it was about to get faster. For comparison, that's roughly 170 times the speed of a commercial jet, and it was already moving that fast before the sun's gravity had even started pulling on it in earnest. Here's where the first real anomaly appears, and it isn't about speed. As 3I Atlas fell inward toward the sun's gravity pulled its velocity up to about 153,000 miles per hour by the time it reached perihelion, its closest approach, on October 29th, 2025, passing within 1.36 astronomical units of the Sun, roughly 203 million kilometers, tucked between the orbits of Earth and Mars. That part was expected. Comets speed up as they fall sunward. Every model predicts that. The anomaly showed up in what the comet was made of. In August 2025, NASA turned the James Webb Space Telescope toward 3I Atlas for the first time, using its near-infrared spectrograph to break down the light coming off the comet's glowing coma into its chemical fingerprint. What came back did not match the comets astronomers were used to. Every comet native to our solar system that's ever been measured this way releases far more water vapor than carbon dioxide as it warms near the sun. Water ice is simply more common in the objects that formed here. 3I Atlas did the opposite. Webb detected carbon dioxide, water ice, carbon monoxide, and a foul-smelling gas called carbonyl sulfide, and the ratio of carbon dioxide to water was the highest ever recorded in any comet from anywhere. Sit with that for a second. This is not a subtle statistical wobble. It is the chemical signature of an object that did not form the way our solar system's comets formed, releasing a mixture of gas that essentially inverts the recipe astronomers expected. Translate that into something you can picture. Imagine every recipe you've ever seen for a particular dish, calling mostly for flour with a pinch of sugar, and then one dish shows up made almost entirely of sugar with a pinch of flour. It's still recognizably the same category of thing, but something about where and how it was made was fundamentally different. Then, months later, after the comet swung around the sun and began heading back out, astronomers caught something even stranger. A delayed release of methane, appearing well after perihelion, rather than alongside the carbon dioxide and water, as though something inside the nucleus was thawing on its own separate timetable, releasing gas the models hadn't accounted for at that stage of the comet's journey. Here is where this stops being an abstract chemistry problem. Every one of these interstellar objects, Oumuamua, Borisov, now 3 Eyes, Atlas, is a physical sample of material from a planetary system none of us will ever visit, delivered to our doorstep by nothing but chance and gravity. We cannot send a spacecraft to another star to study how planets form there. The distances make that impossible within any human lifetime. But when a fragment of that other system drifts through our own, for a few months, we get something no telescope aimed outward could ever give us. A direct physical sample, close enough to study with the same instruments we use to study our own comets. What 3-Eye Atlas is actually made of tells scientists something concrete about the chemistry available for building planets, and potentially the ingredients for life, around a star that isn't our own. That's the stakes underneath all the numbers. This isn't just an interesting rock passing by. It's a message in a bottle from somewhere we will never physically reach. Every planet-forming disk in the galaxy assembles itself from roughly the same basic ingredients, gas, dust, ice, organic molecules, but the exact proportions and the exact conditions, the raw material experiences before it clumps into anything solid, differ from star to star. 3-Eye Atlas is a direct data point in that comparison, a physical answer to the question of whether planet-building material out there in the wider galaxy tends to look like ours, or whether our own solar system's recipe is closer to the exception than the rule. That question sits directly upstream of an even bigger one. How common are the ingredients for life, really, across the galaxy as a whole? But before scientists could comfortably call any of this settled, there was a real crisis of interpretation, and it played out in public in a way most astronomical stories never do. As data rolled in through the fall of 2025, a handful of researchers pointed to a genuinely strange combination of properties. The object's extreme, record-breaking hyperbolic speed, its unusual chemistry, and its size all raised legitimate questions worth investigating rather than dismissing outright. One prominent astrophysicist publicly raised the possibility that an object with this specific combination of traits deserved serious scrutiny as a potential technological artifact rather than a natural comet, and the idea spread fast, amplified by the fact that the comet's most critical viewing window, its closest pass by the Sun on October 29, 2025, happened while 3-Eye Atlas was in solar conjunction, hidden directly behind the Sun from Earth's perspective, effectively, unobservable by ground telescopes for weeks, at the exact moment public curiosity was at its peak. That blackout window mattered. For nearly a month, the object that everyone wanted answers about could not be directly watched from the ground at all, and the uncertainty had nowhere to go but louder. Here's where it gets worse before it gets better. Solar conjunction wasn't a minor inconvenience. It meant the single most scientifically important moment of the comet's entire passage, its closest and hottest approach to the Sun. The point where any hidden structure or unusual behavior would be most likely to reveal itself was happening in a blind spot no ground-based telescope on Earth could see into. NASA's response was to lean on its fleet of space-based assets instead, the instruments that don't care where the Sun sits in Earth's sky. The Hubble Space Telescope, the James Webb Space Telescope, and NASA's Swift Observatory were all tasked with tracking the object through the conjunction period, and in one of the more surprising side results of the campaign, Swift's ultraviolet instruments detected the chemical fingerprint of hydroxyl, a byproduct of sunlight breaking apart water molecules, coming off the comet while it was still nearly 3 times farther from the Sun than Earth is, a distance where sunlight is normally considered too weak to drive that kind of activity. That finding alone forced researchers to reconsider how active this particular nucleus really was, even before the more dramatic chemistry results came back. A nucleus releasing measurable water vapor at a distance where the Sun's warmth is barely a fraction of what Earth receives is not behaving like a simple, inert lump of ice, and that single early clue quietly undercut a lot of the more sensational speculation before it had even fully taken hold. Only in mid-November 2025, once 3-Eye Atlas finally cleared the glare of solar conjunction, did ground-based telescopes get their turn again, and every observatory with the right equipment aimed at the same patch of sky, essentially simultaneously, in what became one of the most concentrated observation campaigns any single object has ever received. Meanwhile, behind the scenes, the actual scientific response was less dramatic and far more rigorous. The Breakthrough Listen initiative, the largest coordinated search for extraterrestrial radio signals ever run, aimed its instruments at 3I Atlas and listened specifically for any transmission that couldn't be explained by natural astrophysical processes. It found nothing. No signal, no modulation, no pattern inconsistent with a lump of ice and rock outgassing under sunlight. At the same time, orbital dynamicists tracked the comet's trajectory with extreme precision, checking whether its path showed any unexplained acceleration, the kind of subtle course correction you'd expect from something under active control, rather than something simply reacting to the pressure of its own sublimating gas, the same physical process that nudges every ordinary comet's path slightly as it vents material into space. The trajectory matched the outgassing model. It matched it closely. Once the fresh post-conjunction images and spectra came in, the picture that emerged was consistent, boring in the best possible scientific sense, and conclusive. An actively outgassing nucleus, a genuine coma, a genuine dust tail, chemistry that was unusual but explainable by natural formation conditions around an ancient, different star. The scientific consensus, stated plainly by the researchers who did the actual analysis, is that 3I Atlas is a natural comet, not a probe, not a ship. A comet, just one built somewhere and sometime very far from anything we've ever measured before. Here is what is happening right now in 2026. In a separate and, in its own way, even more remarkable twist, astronomers discovered that the Vera C. Rubin Observatory, a brand new facility in Chile, still in its commissioning and testing phase, not yet even running its main 10-year survey, had accidentally photographed 3I Atlas before the Atlas telescope ever announced its discovery. Rubin's cameras had captured images of that exact patch of sky going back to June 21st, 2025, 10 full days before anyone knew an interstellar object was there, simply because the observatory happened to be pointed in the right direction while testing its systems. Nobody noticed at the time. The comet was sitting in the data, unrecognized, because Rubin's automated pipeline for tracking fast-moving solar system objects wasn't fully operational yet during those early commissioning runs. It took a dedicated team, led by researchers including Colin Orion Chandler, going back through the archive by hand, developing custom techniques on the fly, to recover those images and pull real science out of them. Precise measurements of the comet's position, its brightness, and the earliest confirmed evidence anywhere of its coma beginning to form. That analysis became the very first scientific paper ever published using Rubin Observatory data, accepted in 2026. Had Rubin's systems been just a few weeks further along in testing, the observatory that wasn't even supposed to be operational yet might have been the one to discover humanity's third interstellar visitor first. Beyond the historical near-miss, Rubin's data added something Atlas's discovery images alone couldn't provide. Because Rubin's telescope is so much larger and its detectors so much more sensitive, the recovered images gave researchers their earliest confirmed look at 3I Atlas's coma actually forming. Direct visual evidence, 10 days before official discovery, that this object was already behaving like an active comet rather than an inert chunk of rock, a detail that mattered enormously once the technological artifact speculation started spreading months later. Meanwhile, the James Webb data kept getting richer. In June 2026, a team using Webb spectroscopy, cross-checked by a separate study using the European Southern Observatory's Very Large Telescope, analyzing the comet's carbon and nitrogen isotopes, arrived at a conclusion that reframed the entire object. 3I Atlas appears to be somewhere between 10 and 12 billion years old, nearly 3 times the age of our own solar system, which is only about 4.6 billion years old. Read that again. This object may have been drifting through interstellar space, unattached to any star, for longer than Earth has existed, twice over. And there is a specific, locked-in date still ahead in its journey worth marking. On March 16th, 2026, 3I Atlas passed within roughly 34 million miles of Jupiter, its final close encounter with anything substantial in our solar system, before continuing outward, permanently on the same hyperbolic trajectory that brought it in. There is no ambiguity in that date the way there is ambiguity in the comet's origin story. No, it was simple orbital mechanics, calculated from a trajectory pinned down by more than a year of continuous tracking from telescopes on the ground, in orbit, and, briefly, in the excruciating detail Jupiter's own gravity provided as the comet swung past. After that pass, 3I Atlas was gone. Not eventually, but permanently. On a path that will never again bring it within a billion miles of anything humans have ever built a telescope to watch closely. This was very likely the only extended look our species will ever get at this particular fragment of another planetary system. And by the time you are watching this, that observation window has already closed. Now, the part that isn't fully resolved, because it genuinely isn't, scientists still don't agree on exactly where or when 3I Atlas formed, or what specific sequence of events sent it drifting for billions of years before it happened to cross our sun's path. One line of analysis, based on its galactic trajectory, suggests it originated in the thick disk of the Milky Way, an older chemically distinct population of stars, which would help explain both its extreme age and its unusual carbon dioxide-heavy chemistry. A separate, competing line of reasoning focuses purely on the isotope ratios measured in its coma, numbers that some researchers argue could also be explained by formation much closer to a younger star system, with the object's ancient age owing more to an extraordinarily long, undisturbed drift through interstellar space than to genuine antiquity at formation. Both explanations are consistent with the same base data. Neither has been ruled out. What most people are not seeing in the headlines is that 10 to 12 billion years old is itself a modeled estimate with real uncertainty attached, not a number etched onto the comet's surface. And the scientists who produced it have been explicit that more data and more time to analyze it will be needed before that age gets treated as settled fact, rather than the leading current interpretation. Even the object's size carries this same kind of honest uncertainty. Early estimates of the nucleus, made while it was still wrapped in a bright coma, were necessarily rough, and it took follow-up observations from Hubble after perihelion, specifically designed to separate the faint glow of the solid nucleus from the surrounding cloud of gas and dust, to even attempt a more refined figure. And researchers were candid that this remains an estimate with real error bars, not a measurement made with a ruler. Zoom out from the chemistry and the dates for a moment, and there's a larger pattern worth sitting with. For the entire span of recorded human history, we assumed everything moving through our sky was, in some sense, ours, born here, bound here, cycling through the same gravitational neighborhood forever. It took exactly 3 confirmed detections across 8 years from 2017 to 2025 to permanently overturn that assumption and replace it with something stranger and, honestly, more exciting. We now know for certain that material from other star systems regularly drifts through our own, and that with the right instruments pointed in the right direction at the right moment, we can catch it, measure it, and learn something real about a part of the galaxy we will never physically visit. The Vera Rubin Observatory, once its full 10-year survey formally gets underway, always expected to detect somewhere between 5 and 50 more interstellar objects like this one, not as one-in-a-generation rarities anymore, but as a genuine, recurring category of object our civilization now has the tools to systematically find. Each one that passes through will be another sample from another star, another fossil from a formation process we can only otherwise theorize about from a distance of trillions of miles. This is what real scientific progress tends to look like up close. Not a single triumphant confirmation, but 2 independent instruments. Built for entirely different purposes, both happening to be pointed at the same fleeting object, and both quietly, separately, telling us the same thing. That the sky above us has always been busier than we assumed, and we only just built the eyes capable of proving it. Think about what that means for the instruments still being built right now, the surveys still in commissioning, the telescopes still being calibrated in labs and mountaintop domes around the world. Rubin Observatory wasn't even finished being tested when it accidentally captured proof of humanity's 3rd interstellar visitor sitting quietly in its own data. That's not a fluke story about one lucky observatory. That's a preview of what the next decade of astronomy is going to look like, as instrument after instrument comes online with more raw sensitivity than anything that came before it, and objects that would have been completely invisible to every previous generation of telescope start turning up in archives almost as a matter of routine. There's a version of this story that ends on a photograph, and it's worth holding on to. Deep in the Vera Rubin Observatory's own archive sits a set of quiet, unremarkable commissioning images captured on June 21, 2025, 10 days before anyone on Earth knew what they contained. A faint point of light drifting across a field of stars, unrecognized, unlabeled, sitting in a hard drive while the observatory that took it was still being tested. Nobody was looking for it. Nobody knew it was there. It sat in the dark, in the data, the same way 3I Atlas itself had sat in the dark for 10 billion years before drifting close enough for any of us to notice, a fragment of some ancient, unknown star system waiting patiently in a folder for someone to finally go back and look. 3I Atlas is already past Jupiter now, already accelerating back out into the interstellar dark it came from, carrying whatever secrets its ice still holds about a planetary system that may no longer even exist, a system that, given the object's staggering age, may have stopped existing in any recognizable form, billions of years before Earth itself finished forming. It is not coming back. Nothing about it is coming back. And somewhere in an archive on Earth, a handful of pixels captured before anyone knew to look for them are the only proof it was ever here at all. So here's everything in one breath. On July 1st, 2025, the Atlas Survey Telescope discovered 3I Atlas, the third confirmed interstellar object ever detected, moving on a hyperbolic path too extreme to belong to our solar system. The James Webb Space Telescope found its chemistry inverted compared to every native comet ever measured, with the highest carbon dioxide to water ratio ever recorded. A wave of public speculation about an artificial origin was met with a breakthrough listen radio search that found nothing, and a trajectory analysis that matched natural outgassing precisely. The Vera Rubin Observatory turned out to have accidentally photographed the object 10 days before its official discovery, becoming the source of the first ever scientific paper published from Rubin data. In June 2026, Webb and ground-based spectroscopy together suggested the comet may be 10 to 12 billion years old, nearly 3 times older than our solar system, though its precise origin remains genuinely unsettled. It made its final close pass by Jupiter on March 16, 2026, and is now leaving permanently, never to return. If you want to see what the next interstellar visitor turns out to be, because Rubin's full survey is just getting started and researchers expect dozens more like this one over the next decade, subscribe and turn on notifications, because I'll be covering the next one the moment it's confirmed. Here's my question for you. If the next interstellar object shows even one anomaly nobody can immediately explain, do you want scientists to take their time and rule out every natural explanation first, or go public with the uncertainty right away? Let me know in the comments. I read every single one.